may be said by one expert, but I have other experts that have a completely contradictory view.
That was a quote from Lucy Letby's lawyer, Mark MacDonald, on the second BBC Panorama show, talking about the insulin evidence in the Letby case. And I think it speaks to the impression BBC presenter Judith Moritz wants to create. The impression being that as the experts have conflicting opinions, we must look to other forms of evidence.
What's being lost is what it was like to watch her in court. When she got into the witness box, 14 days in that witness box, she tied herself in knots.
One issue here is that focusing on her performance in the witness box gives Judith Moritz a tremendous amount of control over the public discussion surrounding the case.
And there were only 4 of us who were there as reporters regularly through in the actual room itself, and being in the room was really important.
Before getting into the main subject of this video, which is insulin, I will just briefly say some of the issues with Lucy Letby's cross-examination stem from the fact that the police got the swipe data wrong. It was reported in The Guardian that Cheshire Police conducted an internal investigation and decided the swipe data only seriously affected the case of baby K. The swipe data issues in the case of baby K have been covered elsewhere and also on this channel in a video I did comparing the evidence of Dr Jayaram's evidence pre and post swipe data error discovery. In short, the revised swipe data looks a lot better for Lucy Letby than it does for Dr Jayaram.
That is a night that is etched on my memory and will be in my nightmares forever, to be honest.
A blogger called Tried by Stats also makes credible arguments that the incorrect swipe data in the case of baby N also makes Lucy Letby look shady, whereas the correct swipe data vindicates her. So now to discuss the main subject of the video, which is going to be insulin. It was stated at the beginning of the video that there are conflicting views amongst experts about the insulin results. However, there is one line of expert opinion which I think is uncontested, and which, if these experts are right, points to Lucy Letby being innocent beyond doubt, at least of the prosecution's theory of poisoning. Before getting into that, first to get into some of the controversy which has emerged with regards to the evidence given at the trial by laboratory witness Dr Anna Milan. Since the trial, Lucy Letby's new lawyer, Mark MacDonald, has been contacted by the test manufacturer Roche Diagnostics about Dr Milan's evidence.
I've actually got the people behind the testing equipment.
The issue which the test manufacturer had was described in this article which appeared in the Telegraph. The problem is that Dr Milan stated in court that the C-peptide result for baby F was in the undetectable range. The C-peptide result was recorded in the lab as being less than 169. She stated in court that it could be 0, it could be 168, or anywhere in between. In the Telegraph article, they say, quote, "The Telegraph has had confirmation from Roche, the company that manufactures and provides the immunoassay, that the lower limit of detectability with a C-peptide assay is 3, not 169. As you will see later, a C-peptide result of 3 is far more suspicious than C-peptide result of 169 picomoles per litre. If you go through Dr Milan's publicly available testimony from the Thirlwall inquiry, which closely mirrors what she said during the trial, she continues to make statements which are at odds with what the test manufacturer has said since the trial. During her Thirlwall inquiry testimony, Dr Milan says, "For the C-peptide, the units haven't appeared on this screen, but it was undetectable. So the bottom of our measuring range, so the lowest we could accurately report was 169. So this was below that, and that's in picomoles per litre. That's the unit for C-peptide. So it could have been 165, it could have been 0. We could not quantitate below that level at that time." I think it's hard to say what exactly has happened here. On the one hand, Dr Milan may have taken a C-peptide reading of 169 and taken it as being an undetectable range, coming from a place of being misinformed about the test parameters. On the other hand, perhaps there is an issue with the reliability of the equipment at the Liverpool lab, which means that they are not able to honour the test manufacturer's lower limits of detectability. Either way, it seems a strange situation to me that the test manufacturer has been speaking out, saying their test has been misrepresented, with the Liverpool lab not clarifying the situation. Either way, the narrative in some places in the media that baby F's C-peptide was undetectable should be taken with the pinch of salt that the Liverpool lab's version of undetectable could contain far higher values than would normally be expected by the test manufacturer. The issue here is that when synthetic insulin from outside the body is used, the body stops producing natural insulin as it is unnecessary. C-peptide can be thought of as being produced as a consequence of natural insulin production, as it is a breakdown product of an earlier precursor molecule. Therefore, if there is absolutely no C-peptide present, it is a sign that the body must have received an insulin dose so high it must have completely shut down natural production of insulin and C-peptide. If you pursue with this video, you will see that an abnormal insulin result can be caused by a fairly rare set of circumstances, although this will be more common if you trawl through notes looking for irregular results. The idea that an abnormal insulin result will be accompanied by an abnormal C-peptide result stretches the probability that there is an innocent explanation. So next, to go through this article, which appeared in the Times, the actual evidence against Lucy Letby. It's one of the more substantive articles which appears in the media in support of the verdict. Reading through the arguments that are made in the Times article, the test results showing that insulin had been given to them was the only piece of concrete evidence of criminality throughout the whole of the prosecution's case. It was the closest thing they had to a smoking gun, and became the keystone for their case as a whole. Letby did not contest the fact that someone had poisoned those babies with insulin, only that it was her who did it, but it is one of the pieces of evidence that has come under scrutiny in recent months, with some experts questioning the accuracy of the method of testing known as immunoassay. So the first thing to say about Lucy Letby's defence here is, if you imagine yourself in her position, what else can you really say? If someone is telling you there is evidence of insulin poisoning, it's hard to say much other than it wasn't caused by you. The problems for the prosecution are that firstly, there are plausible alternatives to intentional poisoning, and secondly, there seems to be a bizarre definition of undetectable C-peptide, which has come from the Liverpool lab and is contested by the test manufacturer. Continuing with the Times article, they cite an expert, Keith Frayne, an emeritus professor of human metabolism at the University of Oxford, who has been using immunoassay for insulin since the 1970s, rejected the notion that the tests were unreliable. Quote, "I don't think many people who know about insulin assays would say you can disregard those tests," end quote, he said. "They are very clear." Looking at these quotes from Professor Frayne, he highlights the importance of the C-peptide results. The Times don't produce direct quotes, but based off their correspondence, they produced the line, quote, "Crucially, C-peptide was undetectable in one baby and very low in the other." So Professor Frayne underlines the fact the C-peptide result is crucial. However, you wonder when he hears the phrase undetectable C-peptide if he is thinking more in line with the test manufacturer's undetectable range or the Liverpool lab's novel interpretation. So next, to look at the insulin cases from a different perspective, which is the feasibility of the prosecution's theory of intentional insulin poisoning. The experts who have looked at this are firstly Professor Peter Hindmarsh, an expert in pediatric endocrinology, Professor Jeff Chase, a mechanical engineer from the University of Canterbury in New Zealand, and Helen Shannon, a chemical engineer who I think graduated from Imperial College London and has applied her skills professionally. So first to consider Professor Peter Hindmarsh, who was the main expert the prosecution used to support their allegations of insulin poisoning at the first Lucy Letby trial. On paper, Professor Hindmarsh would seem to have highly relevant credentials. Whilst all doctors have some knowledge of hormones, and specifically insulin, as an endocrinologist, Professor Hindmarsh holds speciality relates to hormones. Furthermore, he is specialized in treating children and newborns. However, one weakness of his expertise is that he is focused on diagnosing and treating patients. He is not focused on using a synthetic hormone such as insulin for malicious purposes. A further weakness could be that as a human biologist or medic, he's in a field of science that is quite distant from mathematics. Though Professor Hindmarsh does presumably have some level of knowledge of maths, there are points about the calculations in this case which he concedes to on cross-examination. So next on to Professor Jeff Chase, who is introduced as a mechanical engineer. At first glance, I would be a bit skeptical about the prospect of a mechanical engineer overruling a pediatric endocrinologist on an issue such as insulin metabolism or insulin poisoning. However, when you look into his background, he has quite a bit of experience as a biomedical engineer and a surprising amount of experience dealing specifically with neonatal hypoglycemia. Furthermore, he has specifically worked on insulin sensor technology. Helen Shannon is a chemical engineer, which is a field that at least sounds to me like it would be relevant to the insulin evidence in this case. She has been working with Jeff Chase to produce the potentially exculpatory calculations. It is known from Professor Peter Hindmarsh's testimony in court that his theory for the poisoning involved a dextrose bag being spiked to cause a slow and steady insulin infusion. However, there are a couple of issues with this theory. If you look at page 92 of the trial transcript shown here, the note, quote, started by Caroline Oakley / Samantha O'Brien, to note that they signed it out, and then, quote, at a rate of 7.3 milliliters per hour, to note the rate of infusion. Professor Hindmarsh agrees that there has clearly been a new bag hung by someone who isn't Lucy Letby. Brushing past the bag that was not hung up by Lucy Letby, continuing on page 92 of the transcript, Lucy Letby defense counsel Ben Myers puts it to Peter Hindmarsh, quote, you've raised the possibility that given that insulin as a plastic sticks to the plastic, you could have, in effect, sticky insulin coming off. Peter Hindmarsh agrees, Myers continues, and continuing the infusion. Hindmarsh agrees again. Myers then puts it to Peter Hindmarsh, quote, I'm going to ask, surely that must run out at some point. There can't be an inexhaustible supply of sticky insulin over a period of about a day and a half running through this, can there? Peter Hindmarsh responds, that's correct. When pushed by Lucy Letby defense counsel Ben Myers over the issue of insulin sticking to the bag, Peter Hindmarsh eventually says, quote, I don't think anybody's actually done those kinds of studies, to be honest, and I think the answer is we don't know. So here Professor Hindmarsh is essentially conceding that the engineers who are better at maths might have a better knowledge base to calculate how much insulin would stick to the bag. To briefly consider this issue of insulin sticking to plastic, it's a known factor which is part of the reason insulin pens are made partly with glass to prevent insulin being wasted. Dr. Evans says during his cross-examination that it's unheard of for insulin to be added to feed bags. The partiality of Dr. Evans is a separate issue to what's being considered here. There is some research looking at the use of insulin when it is added to total parenteral nutrition bags, which you can see on screen. This is the same type of nutrition bag Lucy Letby is alleged to have spiked. Looking at this quote from the paper, concentration analysis of insulin in the TPN solution have revealed several factors, including the effect of the infusion solution, packaging materials, temperature, and light exposure on insulin, which I think might start to give you an understanding of how difficult the insulin calculation is going to be. This is what Professor Jeff Chase has to say about working out appropriate insulin doses for treatment. Presumably he has similar views on how you would work out the level of insulin you would need to inject from outside the body to cause a certain result.
There's a fair bit of mathematics. So this is where the engineer, if you have the right knowledge of physiology, can come in and create the right model.
If it were a question of physiology, then I would expect Professor Hindmarsh to have a level of knowledge that exceeds Professor Chase. However, in terms of this type of insulin calculation, I think Professor Chase has a fairly rare skill set. Working with Professor Chase, chemical engineer Helen Shannon estimated far more insulin would need to be missing from the storage cupboard than prosecution expert Professor Hindmarsh suggested to cause the insulin value recorded by Baby F's blood test.
The range of answers that we get vary from about 5 times the amount to about 20 times the amount.
For Baby L, the engineers once again estimate far more insulin would need to be missing than the endocrinologist Professor Hindmarsh estimated.
The calculations performed by Jeff and myself range from 20% to 80% of a vial.
Considering that no one noticed or recorded any insulin missing, these calculations create a strong argument to me that Lucy Letby is innocent beyond doubt, at least of the prosecution theory of insulin being added to feed bags. I think I and many others would need to see these calculations reviewed by other biomedical engineers to see if they hold up to be completely convinced of this mathematical model. Professor Alan Wayne Jones is a forensic toxicologist who has seen some of the evidence in the Letby case, though I think not as much as Professor Chase and Helen Shannon. He has described Professor Hindmarsh's use of mathematics at the trial as, quote, bordering on fantasy. It may have been the case that Professor Hindmarsh was relying on the unlikelihood of high insulin / undetectable C-peptide for his evidence, but as has been seen, the idea of undetectable C-peptide is in dispute. This is what Professor Chase would have to say of a C-peptide value of 169 as in Baby F. Though we don't know that was definitely the value, based off this, results in the 130 or 140 range may not be as incriminating as was implied in the court case.
I would say that there are a range of other factors that could make those readings happen like that, given the range of variability that you can see in the neonatal physiology.
So the obvious question at this point is, if there weren't any feedback spike with insulin, what are the alternative explanations? 2 possible reasons suggested by the test manufacturer are firstly elevated vitamin B levels and secondly dead red blood cells. These 2 factors can cause readings which may be off. A further explanation involves antibody interference, which has been shown in immunoassays assessing other hormones and proteins. However, though it was long suspected to occur in insulin immunoassays, as a protein with a unique molecular structure, antibody interference in insulin immunoassays does not appear to have been observed until this piece of landmark research titled Insulin Immunoassay Interference Due to Human Anti-Mouse Antibodies in a Patient with Ketotic Hypoglycemia. The significance of this piece of research may take a bit of getting your head around if you don't have a science background, but I think it is possible. Reading through the study, they acknowledge the general issue of antibody interference in immunoassays for other hormones. Then focusing on this part highlighted in red, quote, to our knowledge, insulin assay interference has not been previously reported, end quote. Looking at the date this study was published, it was published on the 23rd of March 2023 in the Journal of Clinical Endocrinology and Metabolism. This is significant because the Lucy Letby trial started in October 2022, 5 months before this study was published. At a pre-trial agreement for the Lucy Letby trial, it was agreed that 2 babies had been poisoned with insulin, either maliciously or through incompetence. Yet this paper, which comes out 5 months into the trial, provides another explanation for the insulin and C-peptide results. From a legal perspective, the Court of Appeal had previously considered new research as new evidence. Angela Cannings was a mother who was wrongly convicted for murder after 2 of her children died of sudden infant death syndrome. Looking at this quote from the Court of Appeal decision to quash her conviction a year after she was convicted, quote, "Post-trial material which we have received in evidence. Each paper is awaiting publication." This is from paragraph 23, and you can find a link in the description to the full decision. A further line from paragraph 22 of the Court of Appeal decision is semi-famous in miscarriage of justice circles. Quote, "What may be unexplained today may be perfectly well understood tomorrow." So this paper, the substance of which I'll get into shortly, could conceivably be a trigger to provoke a retrial or the quashing of the conviction. I think there may be some variance in how judges will interpret its significance. So to understand why anti-mouse antibodies are so significant, you need to know a bit about how immunoassays are developed. If you take a sample of human insulin and inject it into a mouse, then the mouse is going to develop an immune response to this foreign protein. This gives human scientists an opportunity to capitalize on nature, as the antibodies the mouse will produce will have a very high degree of binding specificity towards human insulin. The next part might be offensive to animal rights advocates, but if scientists then remove the spleen of the mice and then carry out several other steps, they can get to the stage where they can mass produce these antibodies which bind to human insulin, which will be known as monoclonal antibodies. So once you have the monoclonal antibodies which will bind to the protein you're looking to assess, you can go ahead and run the immunoassay. The immunoassay will lead to the formation of sandwiches. So in this study, which showed mouse antibody interference, you would expect what you could call the successfully formed sandwiches to look like this. You have the 2 mouse antibodies sandwiching the insulin. An enzyme, symbolized here as a red star, is added to the top antibody, which is useful for purposes of identification and counting. However, in the blood sample this individual provided for the immunoassay, they also had human anti-mouse antibodies, which will bind to the mouse detection antibodies and throw a spanner in the works. From this graphic, you can see roughly how the sandwiches are supposed to be formed, but the human antibody response to the mouse antibody response creates a problem. To detect this antibody interference, the study authors run another technique called liquid chromatography mass spectrometry, which is more specific and will assess insulin and human anti-mouse antibodies on an individual level, not as sandwiches. Looking here at table 2 from the results, the second and third column show the level of insulin as recorded by the immunoassay second column and LCMS or liquid chromatography mass spectrometry in the third column. Looking at the first row, for instance, they have insulin recorded at 334.05 picomoles per litre when assessed by immunoassay. Meanwhile, they have a slash under the liquid chromatography mass spectrometry heading, which presumably is to signify a 0 value. In every subsequent row, insulin is far higher by immunoassay compared to liquid chromatography mass spectrometry. So remember, in the test for which Lucy Letby was convicted, they didn't do this follow-up technique, and it may have been the case they would have found insulin undetectable if they did the follow-up technique. There are some more quotes from this paper which are relevant to the Letby case. They cite a study to say, quote, "The overall prevalence of human anti-mouse antibodies in a randomly collected sample population was 11.7%. There is some evidence that Roche Diagnostics, the company who produced the immunoassay for the Liverpool lab where the baby F and baby L blood samples were analysed, are in the habit of using mice to produce their monoclonal antibodies. Looking at this study title, comparison of Roche Alexis, note that's the immunoassay used in the Letby case, and Sysmex HISCL immunoassays for the screening of bloodborne pathogens. There's a link to this comparison study in the description. They do make reference to the fact they use monoclonal antibodies derived from mice. I'm not sure if it will be possible to confirm or deny at this point in time if mice were used to produce the monoclonal antibodies that were used in the tests in the Letby case. Even if mice were not used, which I think seems unlikely, it's possible there may be other previously unobserved antibody interferences which could take place. At this point in the video, I think you've seen that antibody interference is possible in an immunoassay. However, you also have endocrinologists publishing papers saying antibody interference in insulin immunoassays did not lead to a published case report until 2023. So whilst antibody interference is possible, it is also rare. However, in the Letby case, if the maths don't hold up, that they didn't have enough insulin missing to cause a corresponding blood value, then antibody interference seems far more likely or possible. Referring back to the Professor Frayne quote / translation in the Times, they say, quote, "Crucially, C-peptide was undetectable in one baby. At this point in the video, we have seen antibody interference is possible, but it is rare. Having an irregular C-peptide result adds to the circumstantial evidence, but this C-peptide result is in dispute." There are a couple more things to say. Firstly, the numbers I have are that there were 3 abnormal tests out of 29 over a period of around 13 months that were focused on. On screen you can see the insulin and C-peptide results for many more tests that were carried out at Liverpool University hospitals over a period of 3 years. You can see some variation, though baby F stands out as a very unusual result. So of those 3 tests out of the 29 at Lucy Letby's hospital that were flagged as producing anomalous results, one of the babies went on to receive a diagnosis of congenital hyperinsulinism at Alder Hey Hospital. So I think that can be discounted as a case of intentional poisoning. The other factor, which I have not considered much in this video, is the issue of neonatal hypoglycemia. There are other commentators out there who have described how this is the least remarkable of the 3 factors that are consistent with intentional poisoning. Those factors being high insulin, low C-peptide, and low blood sugar or hypoglycemia. It was recently suggested by Dr. Richard Taylor that the blood sample for baby F showed high blood glucose, which was inconsistent with intentional poisoning and suggested the test sample had been contaminated.
999 millimoles per litre is what the machine will give you if it's so high at the high end that it's off the scale.
Some people have suggested the glucose value was a default value. If you go by Dr Milan's Thirlwall inquiry testimony, she says, quote, "We never undertake the glucose analysis." So that does seem like a bit of a mistake by Dr Taylor, as the blood glucose would have been analysed at the hospital and the insulin and C-peptide results analysed at the Liverpool lab. So in conclusion, there are 3 major issues with the insulin tests. The first is that the lower end of the C-peptide detectable range was misinterpreted in court. This could be called a procedural error, but if you go by the Times, who are presumably informed by Professor Frayne, it's an important factor. As this was an error in procedure, it could constitute an admissible legal argument that could be used as a factor to argue in favour of a retrial. The second issue is that there is new research now showing that human anti-mouse antibodies can interfere with insulin immunoassay tests. The study authors state that this is the first time it's been observed in the medical literature, and it was published in 2023 after pre-trial agreements had been made. The third issue is the calculation from engineers suggesting they did not have enough insulin missing to cause the corresponding blood values. If these calculations hold up, then for me they provide the most compelling arguments for innocence. However, this is the ground that seems the least likely at this point to trigger an appeal. Even though Professor Hindmarsh admits he doesn't have the maths knowledge to do this calculation, these experts could in theory have been called at the first trial, even though that might not actually have been practical and they may have been unaware of the case.